Hi folks, we're going to take a look at the solution to page 469, number 13a. So here they're asking us to find the angle between these two planes. So we recall that the angle between two planes is the same as finding the angle between two normal vectors. So let's say these are my two normal vectors. Okay, I just find the angle between the normal vectors and I get the angle between the planes. Now one thing to keep in mind is, say instead of, for a particular vector, it wasn't this normal vector but going in the other direction, then you would be finding an angle that was greater than 90 degrees, an obtuse angle. So just recall that we always assume that we're looking for the acute angle between the two vectors. So if you end up getting something greater than 90, just subtract it from 180. All right, so let's find our two normal vectors. So for plane 1, you just look at the coefficients of x, y, and z. So here we have 1, 2, -3. All right, and then for our second plane, our second normal vector, we have 1, 2, and well, there's no z component, so that must mean that the coefficient of z is equal to 0. So we have 1, 2, 0. All right, and in order to find the angle between these two vectors, we just use the dot product. Okay, so we do n1 dot n2, and of course that's equal to the magnitude of n1 times the magnitude of n2 times the cosine of the angle between them, and we can establish all of these values other than the angle, and that's what we'll solve for. So let's do n1 dot n2. So here we have 1 times 1 is 1, plus 2 times 2 is 4, plus -3 times 0 is 0. And here we have the square root of, well, we have 1 squared plus 2 squared plus 3 squared. Here we have, take a look at this one here, 1 squared plus 2 squared plus 0 squared. Don't need that. And then cosine of theta. So theta is going to be equal to the cos inverse of, okay, so here we're just going to have 5 divided by, and now I'm going to divide these square roots to the other side of the equation. So this is going to be the square root of 9 plus 1 is 10, plus 4 is 14. Here 4 plus 1 is 5. Okay, now already looking at this, because I'm taking cos inverse of a positive number, I know I'm going to get an acute angle, so I don't have to worry about subtracting from 180. If this had been a negative dot product, I know I would have gotten an obtuse angle. So let's get an approximation for this here. All right, so let's see what we have. We have cos inverse of 5 divided by, open up a bracket, square root of 14 times square root of 5, and we've got 53.3. Okay. All right, so just to recap here, finding the angle between two planes is the same as finding the angle between the normals, which of course we get by looking at the coefficients of x, y, and z in Cartesian form. And then from there, we use the dot product to determine the angle. If the angle turns out to be obtuse, we subtract it from 180. In this case here, we got the acute angle straight away. All right, that's it for this one.